Hi guys, today we're going to show implementation of a buck converter, which is a voltage lower circuit. This is a power electronics assignment from the Federal University of Santa Catarina, done by Jucélio, Marina, Nelson, and Vinícius. The proposed circuit for our implementation is to turn a 120 or 30 volts input voltage on 5 to 6 volts output voltage with a maximum power of 200 watts.
The principle of working of the buck converter is very simple. It's basically based on two main states, the on state and the off state. The on state is defined when the switch is closed and the main circuit is fed by the main input source, and the off state is when the switch is open and the circuit and the load is fed by its own stored energy of the inductor. Equations.
From the specifications, we define that the maximum variation for the output is 1 volt and the desired output voltage is 5.5 volts.
Our first parameter to define is the duty cycle. The duty cycle is a proportion of the on-state time divided by the total time of the frequency. We have two duty cycles to define, the minimum and the maximum duty cycle, that is related to the maximum and minimum voltage of the input that we allow. The minimum duty cycle is obtained by 8.29 degrees, and the maximum duty cycle is defined by 20.6 degrees.
For the inductor, we set up the inductance at 14.77 microhenry and the current RMS at 36 ampere.
For the diode definitions, we have a delta IL of 3.6 amperes and current in the diode of 35.52 amperes and a RMS value of 35.96 amperes.
For our switch, the maximum current is 2.08 ampere and the RMS current is 8.7 ampere.
And for the capacitor, the calculated value is 4.5 microfarads. The current RMS of the capacitor is approximately 1 ampere. The maximum voltage of the capacitor is 6.6 volts. And the ESR calculated is approximately 0.28 ohms.
According to the values obtained from our equations, we've selected the components for this application. The MOSFET, the capacitor, the inductor, and the diode are the ones mentioned on the table. The total cost of the implementation was around $52. Simulation.
This is the circuit mounted for the project, based on the pulsing simulator. The first case is when the input voltage is 120 volts and the duty cycle is 20.6 degrees. And this is the circuit for the 300 input voltage application. Note that it is the same circuit as before, but now with a duty cycle of 8.3 degrees.
Results.
This is the results obtained for the 120 volts of input voltage. Given a focus in the output voltage, we got the result that consists in the summatorium of the transient state and the steady state. Given a zoom in the output voltage, we got this really stable and steady wave.
As we can see, we obtain a 5.37 average output voltage and a ripple of 0.342 volts.
And now for the capacitor and inductor currents, we got this wave representation.
Zooming the wave, we obtain a 3.53 average current and a ripple of 2.95 ampere.
And now for the 300 input voltage, we got this waveform representation.
Again, zooming the wave, we can see a 5.38 average output voltage and a ripple of 0.351 volts. Thank you for your attention.